Okay, ladies, gentlemen, let's suppose we wanted to do 11.2 number 27, which says f of x is 1 over 50,000 x cubed plus 1/2 x squared. Okay? Then say that again? Yeah. So this is a really small bit, right? Kind of in reasonable places. Like that number is going to be pretty little. Until x gets really big, right? And then cubing it's going to be making it huge. And then that'll kind of cancel out that 50,000 and I'll get like normal x cubed behavior, right? Maybe not cancel out, but overcome at least that kind of drag on there. So part A is asking the opposite of what we just talked about. Part A is asking for small values of x, which of these things is happening or which is contributing most. Yeah, so if you're talking about small, like as in smaller than 1, right? Then cubing things are going to make them even smaller. And then dividing by 50,000 is going to make that tiny little bits, right? So this piece is going to be pretty little, like close to 0. And that piece is going to dominate. You guys see that? After I get past 1, then this x cubed term starts to play more of a role. But it doesn't play that much of a role until it gets to about 50,000, right? It's not even adding 1 until I get to 50,000. And that takes a while. So I'd say the answer to part A, which one dominates, is that 1/2 x dominates because 1 over 50,000 x cubed will be small. Yeah, perfect. All right, part B says I should graph this thing on a window. Is this graph linear? Does this appearance with this graph agree with my answer to part A? So if you graph this thing on a, so we're cutting our window at -10, 10, -10, 10. So let me guess. This thing looks like this.
Yep.
Yep. Give or take. So how did I generate that picture? Yeah, I assumed I was right. You guys see that? Like this thing in there, at that right-hand end, when I plug x is 10 in here, right? I get what out of this? 1,000, right? And so 1 over 50,000 times 1,000 is 1 over 50, right? Which is pretty much freaking 0. Plus 1/2 times 10 is 5, right? You guys see that? So this dot here is at 10, 5 plus 1 over 50, right? It looks like it's pretty much 5 high because it is pretty much 5 high. You guys all cool with that? This dot over here is very similar, right? So it's just a little bit off of 5. You guys all with me on that? Okay, and then why did I know this thing looks basically like a line? Because the smaller x is, right, the less this term contributes. You guys cool with that? So then they asked me, is this thing actually linear? So is it linear in there?
No.
No, it's not actually linear. Right? It's bent just a tiny little bit. Can you see how bent it is? Oh, probably not. Yeah, so this is within 2/50ths on this picture of being linear. Because it's a little bit too low over here and a little bit too high over there. But it's pretty darn close.
4% variation.
Exactly. This is like 3 or 4% variation, so you're not going to feel this, right? This is, oh, yeah, this is less than that. This is very small variation. Guys cool with that?
I still don't understand how you figured out that that was going to be a line.
Oh, I literally looked at this thing and said, this part is basically 0. Right? Because it's really little. It's like 1/50. That's pretty much 0.
Okay.
And so this piece is really the only thing that's happening there. And so I just drew this piece. And then I said, oh, yeah, and the top and the bottom are a little bit. Yeah.
Okay.
Cool? So this is just the tiniest bit then. And then part C, how large a value is required for the cubic term of f to equal the linear term? So what the heck are they asking for? Which one's the cubic term? Yeah, so the cubic term is 1/50,000 x cubed, right? And this is supposed to equal, what's the linear term?
X.
So 1/2.
1/2x. Why is that the linear term?
Because it's not square, it's 1 and 2.
Because that's the line part of it, right? Like that's the thing that looks like the slope of a line. Okay, so when is this the case? What do I need? Oh my god, help. I need algebra.
So you need to solve for x, right?
Yeah, so this should go in your brain as the thing we're going to learn today, which is if there's a rational function, right? Like if there's fractions.
If you think about it graphically, it's when that intersects that.
Good. Yeah, this is when this cubic hits that line.
And this should be 0. That's one.
Good. That's one. When x is 0, they're the same, right? Okay. For rational function land, I don't really deal well with fractions. Get rid of them. Multiply through by that common bottom. So take both sides of this thing, multiply by, what's your common bottom here? That's a common bottom, it's not the common bottom. Well,
50,000.
50,000 is the common bottom, right? That's the best I can do. I don't need that extra 2 because 50,000 already has a 2 in it, right? Okay, so I multiply both sides by 50,000. What do I get on the left-hand side?
X cubed.
I get x cubed, right? And on the right-hand side, I get
25,000.
25,000
X.
x. Cool? All right, now what? Divide by x. Right, you want all the x's on one side. What the hell? I'm going to write divide by x here. I think you really should be a little careful, right? You can accidentally zap one of your solutions when you divide by a variable. So be a little careful there. Just note what would happen if that thing was 0. So that gets me to what? X squared is 25,000.
You want to square root it or no?
Yeah, let's square it. So x is plus or minus the square root of 25,000.
Yes.
Which is 500. Wait. Sure.
It's 5,000. No, it's 500.
Is there an extra 0 in this?
There is indeed an extra zero.
I just did it on
I think there's an extra 0 in this.
Yeah.
Did I do that right?
You almost got me with that one.
Yeah.
So, which is
158.
approximately
Yeah.
158.
So it doesn't.
Cool. So I'm going to leave them here. that guy. You could do a little better than that, right? By, you guys remember how to simplify square roots?
Yeah.
Yeah? No?
Yeah.
Sure. You break out roots inside of it.
Yeah, so you could look at 25,000, right? Break that into 100 and 250. Break that into 25 and 10. Right? I know how to square root 100. I know how to square root 25. 10 I don't know how to square root, so I get 10 times 5 square root of 10. So 50 root 10. But that's the best I can do, and I'd have to approximate that crap anyway.
Yeah.
Cool. So these are where the terms gain equal kind of power, right? Which is way out of frame.
Mhm.
Cool.